The Greatest Show on Earth by Richard Dawkins. Picture yourself as a history teacher who absolutely loves what they do. You're head over heels for the ancient world, the poetry of Ovid, Cicero's speeches, Julius Caesar's military genius. All you want is to share this passion and make the Roman Empire come alive for your students. But here's the catch. Every single day, a loud, well-funded group barges into your classroom insisting that Rome never existed. They claim it's all made up. According to them, Spanish, French, and Italian just magically appeared one day, with zero connection to Latin. Instead of teaching about the Punic Wars, you're stuck defending the basic fact that Rome was real. It would be hilarious if it weren't so draining. This is exactly what countless science teachers and researchers face today. They want to explain evolution, the cornerstone of all biology, but spend half their time defending it against people who flat out deny it happened. Enter Richard Dawkins, a brilliant biologist, who decided enough was enough. With The Greatest Show on Earth, he laid out the complete case once and for all. He realized he'd written plenty about how evolution works, but never put all the proof in one place. That massive mountain of evidence showing evolution actually happened. This book became that case. It sold millions of copies and is now the go-to guide for anyone wanting to understand the evidence firsthand. Dawkins doesn't write like a scientist talking to other scientists. He writes like a passionate teacher, a clear-thinking guide walking you through the greatest story ever told. And today I'm going to share that story with you. By the time we're done, you won't just understand the evidence for evolution, you'll feel its power. You'll learn to see life's story written in your own hands, in the birds outside your window, and across Earth's entire history. You'll cut through the noise and confusion, and maybe for the first time, appreciate the sheer magnificence of this view of life. So let's begin. Let's become detectives arriving at a crime scene from millions of years ago, piecing together the clues that life has left behind. Our journey starts with a simple but powerful question at the heart of so much confusion. When people want to dismiss evolution, they love saying, well, it's only a theory. Richard Dawkins asks us to really think about what theory means. In everyday conversation, sure, a theory is just a guess. I have a theory about why my car won't start. But in science? Completely different ballgame. A scientific theory is a grand explanation covering huge collections of facts. It's been tested, confirmed, and backed up by every shred of evidence we've found. The idea that Earth orbits the sun, that's the heliocentric theory. Germs cause disease, germ theory. All living things descended from a common ancestor, theory of evolution. These aren't hunches. They're the foundation of how we understand our universe. Saying evolution is only a theory is like saying gravity is only a theory. It's a profound misunderstanding. Evolution is a fact, as solid as the Roman Empire's existence, and the evidence is crystal clear once you know where to look. So where do we look? Dawkins suggests we skip the dusty fossils and complex genetics for now. We'll start somewhere much closer to home. We'll start with your dog. Think about the wild variety of dogs out there. A tiny, shaking Chihuahua next to a massive, gentle Great Dane. A sleek greyhound built for speed and a stocky, stubborn bulldog. They seem impossibly different, yet they're all the same species. Even more remarkable, they all descended from one ancestor, the wolf. How did we get from wild wolves to pampered Pekingese in just a few thousand years? The answer is artificial selection. Humans became the selecting agent. For generations we picked the wolves that were a bit tamer, a bit friendlier, and bred them together. Then from their puppies, we chose the ones with traits we liked, maybe a shorter snout, a curlier tail, or a specific coat color. We repeated this process again and again. We became sculptors, but instead of clay, we were sculpting living genes. Dawkins calls this the primrose path to understanding evolution because it's so easy and pleasant to follow. Look at farm animals. We've bred cows producing way more milk than any calf needs, and chickens laying eggs almost daily. Or take humble wild cabbage, a weedy little plant you'd barely notice. In just a few centuries of careful selection, we've transformed that one plant into an astonishing variety of vegetables. Broccoli, cauliflower, kale, Brussels sprouts, and regular cabbage, all descendants of the same wild ancestor, same species, just shaped by human hands for different purposes. This is our first major clue. If human selection creates such dramatic change in mere centuries, what could a different kind of selection achieve over millions or billions of years? This brings us to Darwin's brilliant insight. He realized you don't need a conscious, intelligent selector like a farmer or dog breeder. Nature itself can do the selecting. Dawkins walks us through a beautiful series of stepping stones to show how. Think about flowers. We breed roses for beauty, vibrant colors and intoxicating scents. But who bred the first roses? Long before humans existed, insects were doing the selecting. A flower that was slightly brighter or smelled slightly sweeter attracted more bees. Those bees carried its pollen to other flowers, meaning the brighter, sweeter flower had more offspring. Generation after generation, insects' eyes sculpted the flowers, just as our eyes did later. The flower was simultaneously sculpting the insects, rewarding the best nectar finders and pollen spreaders. This is still selection by an outside agent, an insect, but it's not conscious. The bee isn't trying to create beautiful flowers, it's just following instinct. Now let's take another step. Think about a peacock. The peacock's magnificent tail is a brilliant, shimmering spectacle. But it's also heavy, awkward, and makes the bird an easy target for predators. From a pure survival standpoint, it's terrible design. So why does it exist? Because for generations, peahens have preferred mating with males, sporting the most extravagant, dazzling tails. The tail signals health and strength. A male surviving despite such a handicap must be truly superior. So peahens acted as selectors, not for survival but for beauty. Darwin called this sexual selection. In all these cases, the dog breeder, the bee, the peahen, an outside agent makes the choice. But Darwin's genius was realizing no agent is needed at all. Survival itself is the choice. Imagine gazelles being chased by a cheetah. The gazelles aren't identical. Some, by pure chance, are slightly faster. Which ones survive the chase? The faster ones. Which ones live long enough to have babies? The faster ones. What do they pass to their offspring? Genes for speed. Now think about the cheetahs. Some are slightly faster too. Which cheetahs catch meals and avoid starvation? The faster ones. They also pass on speed genes. Over millions of years, this creates an arms race. Gazelles get faster because cheetahs are getting faster. Cheetahs get faster because gazelles are getting faster. Like the Red Queen told Alice in Through the Looking Glass, it takes all the running you can do to keep in the same place. This is natural selection. Simple, automatic, and powerful enough to explain all the diversity of life on Earth. It's the engine of evolution. But for this engine to have done its work, the world must be incredibly old. Our detective needs to establish the timeline first. Just how old is our planet? History deniers often claim Earth is only a few thousand years old. As Dawkins shows, this isn't just slightly wrong, it's wrong on a mind-boggling scale. It's like believing the distance from New York to Los Angeles is about the length of a football field. So how do we know Earth's true age? We have clocks. Not clocks ticking in seconds, but clocks ticking in millions of years. One of the simplest is the tree ring clock. Every year, a tree adds a growth ring. Good years make wide rings, bad years make narrow ones. By matching unique patterns of rings from living trees to dead wood, then to even older petrified wood, scientists have created a continuous calendar stretching back over 11,000 years. That alone disproves the young Earth idea. But for truly deep time, we need different clocks, radioactive clocks. Certain elements in rocks are unstable. They decay into other elements at perfectly predictable rates. Think of it like an hourglass. When volcanic rock first forms and cools, it's like flipping the hourglass over. It contains a specific amount of unstable elements, like potassium-40, and none of its decay product, argon-40. Over time, potassium slowly turns into argon. Potassium-40's half-life, the time for half of it to decay, is 1.26 billion years. By measuring the potassium-to-argon ratio in a rock sample today, geologists can calculate with incredible accuracy when that rock formed. There isn't just one radioactive clock. There are many, each with different half-lives, perfect for measuring different time spans. Uranium-238 has a half-life of 4.5 billion years. Carbon-14 has a half-life of 730 years, perfect for dating recent things like ancient artifacts. Here's the beautiful part. All these different clocks agree. They all point to the same conclusion. Earth isn't a few thousand years old. It's about 4.6 billion years old. That's an almost unimaginable stretch of time. More than enough for natural selection's slow, gradual engine to have produced today's magnificent diversity of life. With the timeline established, our detective can now examine the clues left at the scene: fossils. Creationists love talking about gaps in the fossil record. They demand to see the missing links. As Dawkins cleverly points out, this is like a defense lawyer arguing that because there's no security footage of the hallway between the pantry and library, his client, who was filmed loading a gun in the pantry, must be innocent. And if the prosecution finds hallway footage, the lawyer triumphantly declares, "Aha! Now there are two gaps, before and after the hallway." The fossil record is actually a bonus. Evolution's case would be rock solid even without a single fossil. But the fossils we found tell an incredible, consistent story. The most powerful thing about the fossil record isn't what we find, it's what we don't find. If evolution were false, we might expect fossils jumbled in any old order. We might find a rabbit in Precambrian rocks, from before mammals supposedly existed. Biologist J.B.S. Haldane famously said, "That's what it would take to disprove evolution." But we've never, not once, found a single fossil authentically out of place in the timeline. And those missing links? They aren't missing. We've found thousands of them. Dawkins tours some of the most spectacular transitional fossils ever discovered. Let's look at one of life's greatest transitions, moving from water to land. For hundreds of millions of years, our ancestors were fish. To live on land, they needed solutions to countless problems: breathing air, supporting weight without water's buoyancy, moving around. For a long time, there was a gap between lobe-finned fishes, with their fleshy limb-like fins, and the first true amphibians with legs and feet. So paleontologists did what detectives do. They made a prediction. They said if we're looking for a half-fish, half-amphibian creature, we should look in rocks of a specific age, about 375 million years old, in a specific environment, ancient river deltas. A team led by Neil Shubin did exactly that. They went to the Canadian Arctic, to rocks of precisely the right age and type. After years of searching, they found it. They found Tiktaalik. Tiktaalik is the perfect missing link. It had fish scales, fins, and gills. But it also had an amphibian's flattened skull and mobile neck. Most importantly, inside its fleshy, fin-like appendages were the beginnings of bones that would become arms, wrists, and hands in every land vertebrate that followed, including you. It had a humerus, radius, and ulna. It was a fish that could do a push-up, the perfect bridge between water and land. The story continues with another great transition: land mammals returning to the sea. Whale ancestors were four-legged, wolf-like land animals. The fossil record now shows a beautiful, step-by-step sequence of their journey back to water. We have fossils like Pakicetus, still mostly land-based. Then Ambulocetus, the walking whale, with legs but powerful swimming ability. Then Rodhocetus, whose nostrils had begun moving from the snout tip to the head top to become a blowhole, and whose back legs were becoming tiny and useless. We see this same story in our own ancestry. The taunt, "Where's the missing link between apes and humans?" is now completely obsolete. The fossils are no longer missing. We have Australopithecus, like famous Lucy, a creature with a chimp-sized brain walking fully upright on two legs 3 million years ago. We have Homo habilis, the Khanty man, with a larger brain, first to make stone tools. We have Homo habiliter, taller with an even bigger brain, first of our ancestors to leave Africa and spread worldwide. The fossil record shows a beautiful, gradual transition from ape-like ancestors to modern humans. The problem isn't lacking links. It's that we have so many that paleontologists often struggle agreeing where one species ends and the next begins. Dawkins argues this is exactly what we should expect if evolution is gradual. The naming arguments testify to how complete the record has become. But fossils are just one evidence line. Our detective has more clues to examine, turning attention to today's world map. Why are certain animals found in specific places and not others? Why, for example, do we find kangaroos, koalas, and wombats? All marsupials, mammals raising young in pouches, almost exclusively in Australia. And why are placental mammals, like us, who nourish young with a placenta, dominant everywhere else? Why are there no native land mammals in New Zealand except bats that could fly there? Why are all 37 lemur species on Madagascar and nowhere else? Noah's Ark offers no explanation. It would require believing all marsupials boarded the Ark, disembarked, then beeline for Australia without a single one stopping along the way. It would require lemurs doing the same for Madagascar. It makes zero sense. But evolution makes perfect sense of it. Dawkins explains this with the beautiful idea of the arc of the continents. We now know continents aren't fixed. They drift across Earth's surface on tectonic plates. Hundreds of millions of years ago, all continents were joined in one supercontinent. Australia broke away long ago when marsupials were the dominant mammals. It became a giant, isolated arc, and the marsupials aboard evolved to fill all available ecological niches, producing marsupial equivalents of wolves, cats, and moles, without placental mammal competition. South America was also an island continent for millions of years, which explains its unique fauna of armadillos, sloths, and New World monkeys. Madagascar broke away from Africa, and the primitive primates stranded there evolved into today's incredible lemur diversity, free from competition with monkeys and apes that evolved later on the African mainland. Life's distribution on Earth is a perfect map of its evolutionary history. As Darwin realized studying Galapagos finches and tortoises, life on any island most closely resembles that of the nearest mainland. It's as if one species had been taken and modified for different ends. Now our detective turns to perhaps the most intimate and powerful evidence of all. History is written all over living creatures themselves. Your own body is a living evolutionary museum. When you get cold or frightened, you get goosebumps. This is the useless leftover action of tiny muscles at your body hair bases. For our furry ancestors, these muscles would fluff up their coats, providing better insulation or making them look bigger and scarier. We've lost the fur, but kept the muscles. They're remnants of our past. Whales, which return to the sea, still have tiny, useless remnants of hip and leg bones buried deep inside their bodies, clear signatures of four-legged ancestors. Some snakes, like pythons, have tiny vestigial hind limbs, little spurs that are the last remnants of legs they no longer need. But the evidence goes deeper than useless leftovers. Evolution isn't like a perfect engineer designing from scratch. It's more like a tinkerer modifying what's already there. This tinkering process leads to truly bizarre, inefficient designs no intelligent creator would dream up. This is the argument from unintelligent design, and it's one of evolution's most powerful proofs. Dawkins's prime example is the recurrent laryngeal nerve in mammals. This nerve controls the larynx, or voice box. In mammals, it branches off the vagus nerve in the chest, near the heart, then travels all the way up the neck to the larynx. In humans, this is a strange but not absurd detour of a few inches. But now consider a giraffe. The nerve still branches off in the chest, near the heart. It then travels all the way down the giraffe's magnificent neck, makes a U-turn around a major artery, and travels all the way back up to the larynx. It's a 15-foot detour. This makes absolutely no sense from a design perspective. A sensible designer would simply run the nerve directly from brain to larynx, a journey of mere inches. So why this absurd detour? The answer, once again, is history. Our distant fish ancestors had no necks. The nerve followed a direct route from brain to gills, looping neatly under a blood vessel. As evolution progressed and necks lengthened, the nerve got hooked on the wrong side of that vessel. Natural selection couldn't start over from scratch. It could only work with what existed, so it simply stretched the nerve, millimeter by millimeter, over millions of generations, resulting in today's ridiculous detour. Our bodies are full of such historical quirks. Our sinus drainage hole is at the top, which makes perfect sense for a four-legged animal with a horizontal head, but is terrible for a two-legged animal with a vertical one. Our backbone is a mess of compromises, poorly suited for upright posture, which is why so many of us suffer back pain. History is written all over us, not in elegant monuments, but in the clumsy, patched-up, wonderfully imperfect way our bodies are assembled. Finally, our detective reaches for his most modern and powerful tool, molecular genetics. If all life descended from a common ancestor, we should see this relationship at the deepest level in our DNA, and that's exactly what we find. The most astounding fact revealed by modern biology is that the genetic code is universal. Every living thing on this planet, from bacteria to blue whales, from redwood trees to you, uses the exact same dictionary to translate gene language into protein language. The letters may spell different words, but the alphabet and dictionary are identical. This is stunning evidence that all life is one big family. We can now compare the exact DNA letter sequences between any two species. When we do, we get a precise measure of how closely they're related. Human and chimpanzee DNA is over 98% identical. Human and monkey DNA is less similar. Human and mouse DNA less similar still. Human and fish DNA even less similar. By comparing thousands of species' DNA, we can build a family tree of all life. And here's the knockout blow to any separate creation idea. We don't have to use just one gene to build this tree. We can use thousands of different genes. And every single time, they all tell the same story. They all point to the same family tree. If a designer had been at work picking and choosing the best genes for each creature, we'd expect to see a jumble. A worm gene might show up in a monkey if it worked well. A fungus gene might be borrowed for a flower. But that's not what we see. What we see is a perfect, nested hierarchy of relationships, a tree of cousinship uniting all living things. The molecular evidence doesn't just confirm the family tree biologists had already worked out from anatomy and fossils. It makes the case so overwhelmingly powerful that denying it means denying modern science's most solid, well-supported conclusions. The evidence is all around us and inside us. Evolution's story is our planet's story, and it's our own story. As Dawkins concludes, echoing Darwin's beautiful final words in On the Origin of Species, there is grandeur in this view of life. From a simple beginning, over billions of years, a process of staggering simplicity, the non-random survival of random variation, has given rise to a spectacle of endless forms, most beautiful and most wonderful. The greatest show on earth isn't a circus or a play. It's the story of life itself, and you're part of it. So what do we take away from this incredible journey through the greatest show on earth? For me, the most powerful lesson isn't just that evolution is fact, but that seeing the world through an evolutionary lens transforms it from a static collection of objects into a dynamic, unfolding story. It gives everything a history, a context, and a sense of profound connection. Richard Dawkins' great gift is communicating not just the what of science, but the wow. He doesn't just present evidence. He invites you to share the wonder. The recurrent laryngeal nerve story isn't just a quirky anatomical fact. It's breathtaking detective work revealing a 400-million-year-old history. The similarity between your hand and a bat's wing isn't coincidence. It's testament to a shared ancestor and life's incredible adaptability. In a world where misinformation spreads instantly, this book is more than a science lesson. It's a lesson in how to think. It teaches us to value evidence, appreciate logic, and have courage to follow facts wherever they lead, even when they challenge our preconceived notions. The grandeur Darwin spoke of is realizing we're not separate from nature. We're its product. We're connected through an unbroken chain of ancestors to every living thing on this planet. We're cousins to chimpanzees, more distant cousins to kangaroos, and still more distant cousins to oak trees and mushrooms. This isn't a demeaning or bleak idea. It is, I think, the most beautiful and humbling idea science has ever given us. It replaces the need for miracles with something far more wonderful, a natural process unfolding over immense time spans that can generate the living world's astonishing complexity and beauty. So how can you start seeing this for yourself? Here are 3 simple things you can do, starting today. First, the next time you see any dog, poodle or pit bull, take a moment to really look at it. Try seeing the wolf still living inside. Notice how it cocks its head to listen, how it interacts with other dogs, its instinct to guard its family. You're watching thousands of years of evolution and selection, both natural and artificial, playing out right in front of you. Second, look at your own hand. Spread your fingers. Notice the 5 digits, the opposable thumb. Now picture a bat's wing, with those same 5 fingers stretched into long, delicate spars. Picture a whale's flipper, with those same 5 fingers hidden inside. You're looking at 3 different solutions to 3 different problems, all built from the same ancestral toolkit. It's history written in bone. Third, if you can, visit a good natural history museum. Don't just rush to the giant dinosaur skeletons. Find the Hall of Human Origins. Look at the fossil skulls. Start with Australopithecus, small and ape-like, then move through time to Homo habilis and Homo erectus. As you look at the progression, the expanding brain case, the shrinking jaw, you're looking at your own family album. You're tracing your own deep ancestry's steps. That was a summary of The Greatest Show on Earth by Richard Dawkins. We've journeyed through his argument's core today, but I'll be honest, a summary is like looking at a Grand Canyon postcard. It can show the shape and color, but can never capture the sheer scale, the awe, the feeling of standing on the edge looking down into deep time. The real magic happens when you read the book yourself. This summary helps you decide if this book is worth your time. If the story of Tiktaalik, the giraffe's nerve, or the continental arcs sparked your curiosity, I urge you to grab a copy. Reading it isn't just about learning facts. It's an experience that can fundamentally change how you see the world and your place in it. A link to the book is in the description. Also, if you found this summary valuable and it sparked a new way of thinking, please show your support by hitting that like button and subscribing to the channel. That way, you won't miss our next journey into another life-changing book. Let's keep learning and growing together.